Are you ready for the fun fundamental theorem of algebra? I sure am. We're going to go through a few problems and then I will actually help you understand and develop an understanding of what the fundamental theorem of algebra actually is. So the directions are to find the roots. Find the roots. What are the roots? I'm glad you asked. I think it's worth saying. Roots is a band that plays on the Jimmy Fallon show. Oh, no, sorry. Roots. These are basically x-intercepts. But I don't want to just confine it to x-intercepts because some roots don't show up on the x-axis. Complex roots, for example, when the imaginary number pops up. But roots are going to basically be x-intercepts, in a vague sense, zeros, solutions. You can call them all kinds of things. But they're the things you get when you set y equal to 0 and you solve. So find the roots. I was going to write a definition, but I've said it. So let's just do it. Number one is f of x equals x to the fourth minus 5x plus 4, x squared plus 4. Okay, we're going to find the roots, and the roots are going to be the things that you find when y equals 0. So we're going to plug in 0 for y, and then we're going to, whoops, not squared, we're going to factor this if we can, and we have gone through some serious factoring. Now, if you're thinking, why don't we just graph it? Okay, fine, yeah, graph, have fun, have your fun. But there are going to be times that not every root is going to show up on the x-axis. I'm just saying, which is why I was reluctant to write the definition of roots and just say, it's x-intercepts. It's not. It's x-intercepts. We technically can call them zeros because it's where y equals 0. And let's just solve this. Enough definitions, let's solve. Okay, no GCF, but I can factor, and so can you. X to the fourth is really x squared times x squared, because 2 plus 2 is 4. And because 4 times 1 is 4, we can do that. And negative 4 times negative 1 is 4. Negative 4 plus negative 1 is that negative 5 I need. Now, I can continue to factor, and so can you. So when we do, we're going to have this first set of parentheses becomes x plus 2 and x minus 2. The second set of parentheses becomes x plus 1 and x minus 1. So now we're in a situation where we need to find out what x could be. Well, if we have a lot of things that are multiplied together, then, and they all equal 0, then one of those factors at least equals 0. So, excuse me, or bless me. Here's what we're going to do. We're going to say that x plus 2 could have equaled 0. And we're going to solve it. And then we're going to say that x minus 2 could have equaled 0. And we're going to solve it. And then we're going to say that x plus 1 could equal 0. And we're going to solve it. And then we're going to say that x minus 1 equals 0. And we're going to solve it. And these are going to be really straightforward because as we go through this process, you're going to say, oh, well, let's see, we'll subtract 2 from both sides. So x equals negative 2. Hey, that's the opposite of the sign I already had. Yeah. Add 2 to both sides. I really don't want to show this work every time. X equals 2. Okay? And subtract 1 from both sides. We won't show this work after this problem unless it's in a different context. X equals negative 1, and then we'll add 1 to both sides, and then cancel those. X equals positive 1. We have 4 roots. They are, it looked like 5 with that marker. Anyway, 4 roots, and they are negative 2 and 2, negative 1 and positive 1. We found all 4 of them. Let's highlight them just for fun. There's 1, there's 1, there's 1, and there's 1. And you know what you could have done? You could have graphed it and found them. Does that always work? No. That's why we factor, so we can find what we need to truly find. So that is the end of the first problem. I would love to show you a graph of it, but I'm going to hold off on that. And we're going to actually jump into the second problem and kind of run into some issues. So we're going to find the roots of this next one. So let's do it. You ready to run into some mathematical issues? 2x cubed plus 3x squared minus 14x minus 15. Okay, there was a strategy we used in a previous lesson where we looked at this and said, oh look, 4 terms. Why don't we factor by grouping? Yeah, and so we'll try it. And I'm going to just go ahead and not waste too much of your time here. It's not going to work. It's not going to work. So we're going to have, let's see, x squared factors out of the first 2 terms. 2x plus 3 here, and negative 1. We'll factor that out, and that gives me 14x plus 15. And I am very tempted to continue factoring by grouping, but I can't because these two sets of parentheses are not equivalent. So I've done all I really can do. Now, if you're looking at this and saying x squared minus 1, that's x plus 1 and minus 1, I hear you, but it gets me nowhere. So this is, yeah, that's a disaster, isn't it? Quite a disaster. Very difficult to factor using the techniques that we have. So we are going to graph this one. Now, let's back up for just a second, because we're going to just jump straight into the fundamental theorem of algebra as we discuss what happened. How many roots did we have here? 4? Yeah? Okay, yeah. What was the degree of this? 4? I wonder if it's a coincidence. Okay, so hold that thought. What's the degree of this? 3. Highest exponent is a 3. I wonder how many roots we're going to have. Let's try. So let's go to browser. And this is the very first problem. This is the first one we did. And again, notice your roots, which are x-intercepts. But it's not always confined to what you can visualize on the x-axis. And you're going to encounter that later. Oops. There they are. There are your 4. That was not too bad. Now, here's the second one. That was much more difficult to factor. -3, -1, and 2.5. And that's what made it so hard to factor. So we don't really want to play that game with that one. We have 3 roots on this one, and they are at -3, -1, and 2.5. How do I know that that's how many roots I have? Now, it goes back to just a vague connection we just made. The degree of this problem is a 3, so it's going to be 3 roots. Now, again, we're going to explore that some more as we go, but that is the fundamental theorem of algebra. It's not really written in words yet in this lesson, but that's it. So I'm going to go back to the problem, and we're going to write those 3 things down, -3, -1, and 2.5, that we did not get from factoring. We got them from just graphing and then saying, you know what, the degree was 3, I found 3 roots, we're done. Really? It works that way sometimes. So let's go. So this got me nowhere. Thanks a lot, factoring strategies. And I end up with -3, -1, and 2.5. It was -1, am I right? No. Yeah, I think it was -1. Let's double check. I'd hate to write that down wrong. Yeah, -3, -1. All right, so that's it. We had those 3 things, and because we had a degree of 3, we had 3 roots.